Today we have a class for class 10th based on the topic arithmetic progressions. Arithmetic progressions. Okay. We know what is progress mean, which is increasing continuously. Here we add the word arithmetic. Here the progression is related to the numbers. The numbers increase or decrease by a certain rule or certain method, we call that pattern is a progression. Suppose let's see, of course we used to write this type of numbers in the earlier classes, that is primary level. See, I write here some set of numbers. This is one set. We are used to answer the next three questions in the primary level. This type of questions. But in the higher level, you are given the same type of questions in such a way as yes, okay. We call them patterns, pattern of numbers, because each pattern follow a specific rule or specific increase or decrease. Let me write one more pattern. Okay. We can't say the progression of numbers is always in increasing order. It may be in decreasing order too. Anyhow, the increase or decrease must follow a systematic way. So whenever a pattern follow a particular sequence of increasing or decreasing, that patterns are called sequences. We call all them sequences. Because they follow a particular trend. Here there is a set of natural numbers. For every natural number is one less than its successor. See here, 1 is 1 less than this, or 2 is 1 more than this. By adding 1, I get the next member in the sequence of this series. 2, 4, 6, 8, 10. These are the natural numbers. By adding 2 always, I get the next even number. And 1, 4, 9, 16, 25. These are the squares of the natural numbers. Natural numbers we know that is 1, 2, 3, 4, 5. 1 square is 1, 2 square is 4, 3 square 9, 4 square 16, 5 square 25. Here also the numbers in the pattern follow a particular rule, that is squares. And 3, 6, 9, 12, 15, these are the multiples of 3. We know L. So every time by adding 3 I get the next successive multiple. And whereas here 18, 16, 12, 14, 12, 10, I get the next number by decreasing the same value every time. See, 18 is decreased by 2 to get 16, and 14 is decreased by 2 to get 12, and 10 is to be decreased by 2 to get the next and next numbers. These are all sequences. So we define the sequence in such a way that a sequence is a set of numbers followed by a definite rule. If we derive a rule for each and every pattern here we describe, we can write any number or any member in the series. Suppose in the series we have 1, 2, 3, 4, 5 terms in the sequence. What the 10th term? If I derive a sequence, a rule, I can write the 10th term, whereas here also I have the squares of first 5 natural numbers. What is the square of 9th natural number? If I derive a rule, I can go there directly without writing all in the sequence. So the rule helps us to find the required member in the series or in the sequence. Let's derive the rule for all these now. Let's take the first series or the first sequence of numbers, that is 2, 4, 6, 8, 10. If I take the first term is A, it is 2 times of A. That is 2 into 2 value. This is 3 times of A. This is 4 times of A. 5 times of A. If I continue writing the series, what is the nth member in the series? Nth member. It is the first member. So 1 into A. There is the second member. So 2 into A value. Third member. Fourth member. Fifth member. Nth member. It's very clear. You can answer this. That is 2n. We want the 10th member in the order of this sequence. 10 into 2, 20. Clear. Now let's take the second. Here each member is the square of the natural numbers. So 1 is equal to 1 square, whereas the second number is 2 square, third member is 3 square, and fourth member is 4 square, and fifth number, that is 25, is 5 square. These 1, 2, 3, 4, 5 are natural numbers. So what is the nth member in the series? What is the nth member? Of course it is n square. So we can use the rule for this sequence n square, and for this sequence 2n. Let's see the multiples of 3. The first multiple of 3 is 3 into 1, of course 3. Second multiple of 3, 3 into 2, 6. Third multiple of 3, 9. Fourth multiple of 3, 12. Fifth multiple of 3, that is 15. What is the nth multiple of 3? 3n. See how simple derive a rule for the sequence of numbers. So what is the 10th term in the series now, or 10th value? 10 into 3, 30. So 3n is the rule for this sequence. Let's find out the rule for the last sequence or the pattern. Here first member is A, second number is obtained by subtracting 2. Clear? So 18 minus 2. And third member A minus 4. See, 18 minus 4 is 14. Next this A minus 6. A minus 8. So if the second number, this is second number, of course I write A2, A3, A4, A5. Okay. So what is the nth term in the series? Nth term or nth observation in the series when the sequence is in the decreasing order. So these are the A1 is equal to 18, A2 is equal to A minus 2, A3 is equal to A minus 4, A4 is equal to A minus 6, A5 is equal to A minus 3. Suppose if I want term 10, of course it is begin with A minus some value. But what to be subtracted from A? Let's follow the sequence here. First term is A. Since we know it is decreasing by 2, so what is subtracting from A? 2 into 0 actually. 2 times of 0. Nothing we are subtracting from the first term to get the first term. For the second term, 2 into 1 we are subtracting. Clear? And second term, third term, 2 into 2. Third term. Now can you imagine the 10th term? the 10th term, that is a minus 2 into 9, that is n minus 1, 10th term. Now, the general term of the series an is equal to a minus 2 of n minus 1. Okay, this is the general term to find any member in the series. So let's find the sequence of numbers by using the rules derived already. So the rule of any expression is an algebraic expression. See here, 2n is an algebraic expression, it is a monomial. For this n square, it is also an algebraic expression monomial. And the third one, which is 3n, is an algebraic expression monomial. The last one, a minus 2 of n minus 1, is an algebraic expression, of course binomial. So the rules of any pattern or any sequence is always a algebraic expression. So let's find some more rules and also sequences with the rules derived already. Let's have some examples in our next video. Please keep watching my channel so that you get the regular updates of the same chapter, so that you get the benefit forever. Thank you for watching.